So hello everyone, my name is Patel Srujal. I am from Chartered University. I am here to explain about the topic right policy in cache memory, as you can show in the background. This is the topic of our syllabus COA. So we have to discuss about in the 3D animation. So as you can see, let's start the animation. Okay, as you can see, in modern computer system, data moves between three major components: CPU, cache memory, and main memory. CPU process the data. Cache act, uh, Cache act as a high-speed buffer and RAM stores larger amount of data. As you can see, CPU can transfer data to main memory and cache memory, L1 cache memory also. So, but important questions arise when CPU writes the data, where it should be go. This brings important cache write policy, write through, write back, and write around. So, from the next animation, we see the for to understand the policies, we must first understand the memory hierarchy. So as you can show, at the top we have the register. Okay, let just pause the animation. Okay, as you can show as a first here, it is shown as a register. It is the fastest and smallest in memory. Then after that L1, L2, L3, and followed by RAM and finally storage. As we move downward, as you can show in animation, memory becomes slower, but in size, comparison in sizes get larger. Hierarchy is the reason why cache exists to reduce excess time and improve performance. So let's start with the write policies, going to the write through. In this approach, every write operation updates both cache memory and main memory. As shown in CPU sends data through both RAM and cache memory also. So this ensures the data consistency. Main memory always have a latest value. However, it comes with the cost. If anything has advantage, it also has a disadvantage. Write to the memory increase the traffic and slow down the performance. So write through is a simple, safe, but slower. Key points of that is always consistent, simple to implement, but higher bus traffic and more memory writes. So moving toward the next topic, it is a write back policy. As you can show, data is written only to cache first. The cache marks data using dirty bit. As you can show, cache uses dirty bit, indicating it has been modified. Meanwhile, RAM still hold the outdated or stale data, eh, like not latest data. Meanwhile, RAM hold only when cache block is replaced. The updated data is returned back to the memory. This reduces the memory writes and improves the speed. But there is a risk if the system crashes before writing back the data may be low. So conclusion of that is write back is a fast, but what we can say it is a fast but more complex and slightly risky. So reduce the memory writes, faster CPU performance, but a risk of data loss, complex implementation. Moving to our next policy, write around policy. In this method, the cache is completely bypassed during the write operation. The CPU writes directly to the RAM. This avoids unnecessary cache updates, especially for data that won't reused. However, since cache is not updated, future reads may be result in cache misses. As a result, write around is efficient for large amount of infrequent writes, but may reduce the read performance. So it avoids the cache pollutions, good for large sequential write, read penalty one miss, and cache is not updated. So let's compare these three policies through a table. As you can see in the table, write through updates both cache memory and RAM also, offering high safety but lower speed. Where write back updates only cache, giving high performance but medium reliability. Where write around bypasses cache, reducing overhead but increasing cache misses. So each policy is designed for different use purpose case. What are the requirement? On the basis of that, we can choose the policies. So based on that, there is a COA relevance topic. Catch right policy is the essential part of a COA. These are directly related to memory hierarchy and cache design and CPU performance optimization. This concept Based on this concept, it is also important for the competitive exam like gates. There are many questions from this right policies can ask in gate exams. So let's summarize this. Right through is a safe but slow. Right back is a fast but complex. Right around is a direct but may cause catch misses. So choosing the right policy depends on requirement and performance goals. So that's it. It is the end of my presentation. Thank you everyone for listening.